I'm going to share again the PPT. Hope the PPT is visible to you all. So this is our unit 3 content. Already we started with the connecting devices, that is networking devices. Last class I started. So just below the physical layer, we have the hubs. Hubs are nothing but the connecting points between two different ends. You can able to see the functions of hub. Then we have the next different connecting device. The first one is the hub. We can able to see we have different devices in the Ethernet, and in a star topology, if they are to be connected together, we use that connecting point. That meeting point or the connector used to connect the different systems together is said to be called as the hub. So hub is not going to have any intelligence, just is going to be acting as a connector. The next type of interconnecting device, which is responsible for transfer of data in the physical layer, is said to be the repeater. So repeater, from the name itself, you can make out it is going to repeat what it is going to get. So that is if your LAN length is said to be a smaller one, or if you want to connect two devices where the size of that the connecting link is said to be more, then we in that place you can divide the entire segment between the source and the destination through the LAN if you are connecting, to the Ethernet cable if you are connecting. If you can divide that length into two half, and if you insert the repeater in between, then that repeater can be used. Just a second. So that repeater you can use for connecting the segments. Okay. So this device, again, repeater is not going to have any intelligence. So whatever data it gets from any of its terminal, from any of the device, it's just going to transfer to all the connecting device in the repeater. So you should not misinterpret the repeater for an amplifier. As you know, amplifier is going to amplify, whereas repeater is just going to repeat. So you can able to see in this example, we have the data bit 14010, and we have on the other side also the same data bit being transmitted. The only difference between the two is we use a repeater there. That is, if a packet or if a frame has to be transferred from A to D, then this length, connecting length between from A to D is said to be very large. If you are using any Ethernet cable, then we have some restriction in the length. But I can reduce, it means I can just connect a repeater here in between, so that I can able to connect these two ends A and B, these two devices together without any compromise in the data, that is the performance or the data rate that is transferred. So that is the function of repeater. Already we have seen, and you see repeaters are responsible for transfer of data in the physical medium. So what is the main problem associated with the repeater? So the first problem is it's not possible for the repeater to control the traffic. As I told you, whatever bits or whatever data it is getting at the sending in, it will send it out to all the connected devices in the repeater. So there is no something, any kind of intelligence or filtering operation possible with this repeater. So that is the main problem. So at a time, if two or more devices, they are trying to connect, I mean, when they try to send the data, then of course it will result in the collision, which is actually an undesirable phenomena in the physical layer. To avoid this or to eliminate the disadvantage of this repeater, we go for using the next type of internetworking device, that is said to be called as bridge. Okay. So bridges are meant for solving the problem with the traffic on a network, so that collision in the internetworking is said to be avoided. Okay. Next, it's going to again eliminate the unnecessary traffic. It's because we are going, this bridge is capable of transferring the data that is the frame from one source to the destination without, it's not going to send it to all the devices connected to it. It's just going to identify the destination and it is going to send the frame only to the destination address. Okay. So these bridges, they operate both in the physical and the data link layer in the OSI model. And actually, these bridges, they are capable of dividing a larger network into smaller segments so that it can able to actually identify the destination address and it can able to send the frame to the destination address, not to all the connected devices in the network. So in this way, they actually they filter the traffic. So because of that, it is capable of controlling congestion as well as isolating problem links. And it's also capable of providing security. So this is how a bridge is said to be connected in the OSI model. We see it's going to divide the device A and B. They need to be connected, and then we have them in a segment, two segments through bridge. They are said to be connected. And you see, we have a LAN 1 on the top side with 4 devices connected, A, B, C, D, and LAN 2 on the bottom side, E, F, G, H. And if they are need to be connected, then we use bridge there. Bridge is actually a 2-port network. It's said to be having a 1 port. It is having only 2 ports, port 1 and port 2. So different ways the bridge is useful. See here. See here, A wants to send the data frame to D. Now, as A and D, when the bridge finds the data has to be transferred from A to D, it will have a table. That is, we call it as the bridge table. From the table, it will come to know whether A and D belong to the same LAN or a different LAN. So in the first diagram, as A and D belongs to the same LAN, it will not forward the frame to the port 2 of the bridge. Whereas in the second diagram, if A wants to send a packet, a data from A to G, then as G belongs to, bridge will identify that G belongs to some other LAN. So it will forward the frame that is from port 1 to port 2 through the bridge, and it will reach the destination address, that is G. So we see that these bridges operate in the data link layer. Now, another example of how actually a bridge identifies the destination. So using the MAC address, that is, the bridges will have a table which is said to be called as the bridge table. So using the MAC address of each and every device, it will identify whether those devices are connected to port 1 of the bridge or port 2 of the bridge. Suppose that is, if any frame comes to port 1 of the bridge, then from the table, bridge will immediately refer to the table. And from the table, if the destination belongs to the same port, it will not send the frame to the other port. Whereas if the destination address is available in the other port, it will send the frame through the bridge to the other port. So by this way, it actually avoids the the congestion, and also it is capable of identifying the destination, and the collision problem is avoided here. But with the bridge also, this example, I think last class I told you about this example. So in this example, we have 3 LANs connected together by using a bridge, and the way the bridge table is updated is shown here. So initially, the bridge table is said to be empty, and from the frames that the bridge receives, it will update its table. So initially, we assume that A wants to send a frame to D. So from the frame that A is going to, that is bridge is going to receive, it will come to know that A belongs to port 1. So it will update its table with the address as A, and the port associated is port 1. Then again, we take E is sending a frame to A. So from the frame that this bridge is going to receive in the port 3, it will come to know that E is associated with port 3, and it will update its table that E with port 3. As already A is found to be associated with port 1, from the table, bridge will come to know that it has to forward the frame to port 1, and it will forward it to port 1, and it will reach the destination address A. The same thing is repeated where B wants to send a frame to C. So there is no updation. That means there is no entry for B. So from the frame that this bridge is going to receive, it will come to know that B is associated with the port 1, and it will update itself accordingly. So this way, this bridge will be updated. The bridge table will be updated. So these bridges will be having certain intelligence, or it follows an algorithm such a way that this bridge is said to be updated. So there are two ways, there are two types of bridges. One is the static bridge, the other one is dynamic bridge. So static bridge, we have the bridge table being static, and in dynamic, they are said to be adaptable. That it means they are capable of changing itself as per the package that the bridge is going to receive, as well as from the package that it is going to send. So what is the problem associated in bridges? Very important, ma. Just a second. What are the problems that are associated with the bridge? So when we take a transparent bridge, we find always in a transparent bridge, there will also be one other bridge associated. So that in what they actually meant by transparent bridge, in a transparent bridge, neither the sender nor the receiver will have any knowledge about the bridge. It will not even know that a bridge is there to connect the two different lands together. So that is the transparent bridge. So in that case, if something happens, malfunction happens with the bridge, then there will not be any connectivity between the two networks. So always in transparent bridge, one more extra bridge. So here we have bridge 1, isn't it? We do have one other bridge, which is going to be connected in the same way, which is going to do the same functionality of bridge 1, will also be connected. Why actually this is done? This is done because it's just meant for some emergency. Like if bridge 1 is said to be damaged, then the function, that network will, the connectivity will not be lost. So the function that is done by bridge 1 will be taken care by bridge 2. So that is the purpose of adding a redundant bridge, but that actually will pose a problem. We call it as the loop problem. Just an example, you take this first diagram. The first diagram, you see we have LAN 1, and to the LAN 1 we have two devices, that is device A and device B, means the device with address A and address B. Likewise, we have another LAN 2, to which we have two device address, device C and device D, and they are said to be connected using bridge 1, and there is also one other redundant bridge, that is bridge 2. So initially, the bridge address for both bridges 1 as well as for bridge 2 is said to be empty. Now, just we take the first scenario, A station wants to send a frame to D station. So with no information regarding the port and the associated address, bridge 1, when it gets the frame from station A, it will, as it does not have any information relating to the destination station, that is station D, it will flood the the network with the frame that it receives from A. So what is meant by flooding? It means actually this bridge 1 will just forward the frame to the port 2. Okay, so here also we will have the frame that is sent from device A. Likewise, bridge 2, when it receives a frame from device A, it will also it will not be knowing the destination address. So it will also flood the network with the frame that it receives. So, and it will come to know that the address A is associated with port 1. Likewise, bridge 2 also will update its table that bridge that is port address A is associated with port 1. So the frame will be available now in that LAN. So in the LAN 2, but instead of having one frame that is sent from A, there is going to be two copies of the frame. Why? Because as both the bridges are not knowing about the destination address, that is the address of station D, they will just flood the network with the frame that it receives. So what happens here in the third case? In the third case, as bridge 2 is going to flood the network, the frame that is received from bridge 2 will reach the bridge 1. And bridge 1, on seeing a frame coming from port to 2, will find that the source, that is the address for the device, that is the address for the device, that is address for device A is said to be associated with port to 2, because the same frame is received from, because as bridge 2 is going to send the frame from its port to 2, this frame from bridge 2, when it is received by the port 2 of the bridge 1, it will misinterpret that A is associated with port 2. Likewise, the frame from bridge 2, when it is received in the LAN 2, when it reaches bridge 2, it will also misinterpret that A is associated with port 2. So A in both the actual bridge table, A address will be entered as associated with port 2. Now, again, when the same frame, when it is here in the port 2, as it does not know, again, still the identification of the address of station D is still not known. So when it reaches here in this part, it will again, the bridge will refer to the table. There is no entry for D. There is no entry for D in either of the bridge. Again, what it will do, it will flood the network with the same frame. So again, the frame which is available here will be sent here. Again, the same process from here. This is a repetition. Now the frame on, when it is reaching the LAN 1 from both the bridges, again, it will go here and it will look into the address. As there is no entry for D, it will again flood the network with the available frame, and the process will be repeated. So again, A will become 1 in the table. Again, here A will become 2, and you will find that the same thing, the same process will be repeated indefinitely. So here the purpose of a bridge here is to send the frame from A to D, but nowhere it is satisfied because it has entered into a loop. So this is called as loop problem in bridge. So in order to avoid this loop, it means there should not be any closed path. So using bridge, if you connect the network, you have to see that the network, nowhere it is going to make a closed path. Okay, so that is the solution to avoid the loop problem in bridges. Hope it is understood by you all. Yes, is it clear? Give me some response. So we have the loop problem. So this is called as the loop problem in bridges. So in order to avoid or in order to eliminate this loop problem, we go for an algorithm which is called as the spanning tree algorithm. So in the spanning tree algorithm, let us just take an example. So we have the device A, we have the device B, we have the device C. Okay. And you assume they are connected. This is the network used to connect them together. Now, if there is a possibility, this is a closed loop, isn't it? If there is a possibility of, if a frame is sent from A and it has to reach C, if there is a path for from A to C, then there is every possibility of the frame reaching the same place again. So that is the loop problem which has to be avoided. So the ultimate aim is to connect, the network should connect all the devices, but it should not make any closed path. So this is the aim of the spanning tree algorithm. So the number of steps you can able to see. If you follow the steps, you can arrive at a network with no closed path. So it goes like this. First, you have to identify from the network given, you have to identify the root bridge. So we'll just go for the next slide. So look at the first, first network. As you see here, we have 4 LANs. LAN 1, LAN 2, LAN 3, and LAN 4. And we have 5 bridges. Bridge number 1, 2, 3, 4, and 5. So the very first step in the spanning tree algorithm is to number the bridges. So as I am having 5 bridges, I just number them as bridge 1, 2, 3, 4, and 5. Then the next step is to mark the bridge with the smallest number as the root bridge. So here the black colored bridge B1 is the smallest number ID. Among 5, B1, B2, B3, B4, and B5. Among this 5, B1 is said to have the smallest number. So I mark this bridge as the root bridge. Okay, then what is the next step? We'll just go to the previous slide. And then what we have to do after this, we have to mark one port. As you know, bridge are 2 port devices. So we have to mark among the 2 port, one port as the root port, which means if I travel through the port from that bridge, if I travel through the port, which you call it as the root port, you have to reach the root bridge with the minimum cost. So what is actually meant by minimum cost? The cost function here, the associated cost function in the spanning tree algorithm could be anything. It could be the path that is taken which has minimum hops. It could be the path with minimum delay, or it could also be the path with maximum bandwidth. So anything it could be, but generally we call them as the cost function. So based on the cost function, among the 2 ports associated with each bridge, we mark root port as one of the port as root port. So let us take this network and we have identified the root bridge. Now, if you look into one by one, we will look into. So we have bridge 2. So for all the bridges, we have marked the numbers for each of the ports. So for bridge 2, 1, 2, bridge 5, 1, 2, bridge 3, 1, 2, bridge 4, 1, 2. Now, if you look into the bridge 2, if I have to reach the bridge root bridge from bridge B2. From B2 to B1, if I have to move, I can go through port 1 or I can take the route from port 2. But as I am reaching here, if I start from port 1, I can reach the root bridge more easily than I take the port 2. Because if I have to take from port 2, I can only go by taking from port 2, I should reach bridge 3, only then I can reach bridge 1. But if I take this port 1, I can easily go to the corresponding root bridge more easily. So I mark this segment as the root port. So again, if I take this bridge B3, as you can able to see here, among the 2 ports 1 and 2, port 1 is directly connected to the root bridge, whereas if I have to take port 2, then I have to go to bridge 2 to reach bridge 1. If I'm taking this route from B3 through port 2, I have to go through B5, B4, only then I can reach B1. So I mark this port as root port. Likewise, if I take B4, it's very obvious that you can easily reach this root bridge from port 1 of bridge 4 more easily than port 2. So I mark this port as root port for bridge 4. Now, if I take bridge 5, you can reach the root bridge through port 1 of bridge 5 or port 2 of bridge 5. So if I take the route that is through port 1, then I should take the path B2 to B1, or I can take the path B3 to B1. I can take the path B4 to B1. Among this, it's based on the cost function associated. Here I'm taking the cost function that I'm choosing the path where it has the maximum number ID. Okay, so it depends on the system admin. So so it is dependent on the cost function. So I told you know earlier the cost function. So the cost function, if I find two routes making the same cost function, the one that you choose depends on the system admin. So you can able to choose only one among the two. So here I am choosing this port as the root port because as per my cost function, I am choosing the route or the port which has connected means which has connectivity to the number which is higher among the three bridges. So we here I have bridge 2, bridge 3, bridge 4, but I choose only this path. So I choose the port 2 of bridge 5 as the root port. So once we have identified the root port, then the next step is to identify the, just a second, we'll move back to the next step. So we have to go in for identifying the designated bridge. So what is actually the designated bridge? You have to find out the shortest path of every bridge, I mean of your land from the root bridge. So we should go for we have to look in for each of the land. So we have land 1, through which port of the bridge if I travel, I can easily connect the land to the root bridge. So if I have to connect land 1 to bridge 1, then the most suitable way or the most suitable port which I can use is port 1. So I call this port as the designated port. Likewise, land 2 to bridge 1 is possible only with this corresponding port. So I call this port as designated port. So if I take land 3, likewise land 3, if I have to take, if it has to be connected to the corresponding root bridge, I can take I'm taking this path. It's because here I can take to go from land 3 to connect land 3 with the root bridge. I can take the that is bridge through bridge 2 or through bridge 5. If I take bridge 5, then I have to move to bridge 4 to reach B1. But if I take this corresponding bridge 2, then it through bridge 1, I can easily get the root bridge. So I am taking this bridge or this port as the designated port. So this is there, this is there, this is also there, this is also there, this is there, this is also there. And again, we have this bottommost land. So we have land 4. Land 4 can be connected to the root bridge through bridge B4, through bridge B3, and through bridge B5. But it is easy for me through bridge B4 if I connect, it is easy for me because if I take bridge B3, then I should go, means I can say even through bridge B3 I can do, even through bridge B4 I can do so, but I am taking that this path through the port 2 of bridge 4 as the designated port, because as per my cost function, if I find two things match, I am going to choose the one which has the highest bridge ID number. So this I consider as the designated port. So we have marked everything. Now we will move on to the next slide. So what I do here is I'm going to take all these ports which we have already marked. How can the students like me in placement learn this as we are in placement class? We are going to upload this video in the in your LMS mark. So you can refer to the video. We will be coming to class, right? That time we will clarify the doubt. Okay. Okay, thank you. So we have LAN port and I have drawn everything, all the root port and the designated port. What we have already marked. I have drawn it with red line. Now, what is not there? That this one has no connection. Means this one we call it as the blocking port. This port is also said to be blocking port and this port is also said to be blocking port. As such, I can say like this. So we have the 5 bridges here. We have 5 bridges here. And we have, if we have all the ports connected through segments, then this is one closed path, this is one closed path, this is one closed path. But what I'm doing here is I'm removing this segment, I'm removing this segment, but I'm removing this segment. But still I have connectivity among the ports as well as with all the LANs. So we have a connection from bridge 1 to bridge 2 through this LAN and through this segment through the port. Likewise, I have connection from this LAN to the other LANs, and I have connectivity, but I still have no closed loop here because I have blocked this port is considered as the blocking port. I hope this is clear. We'll move on to the next slide. So we see and erase the annotations. So those ports which are not marked either as a root port or the designated port now can just be removed. So we call them as the blocking port. So we can able to see here that port 2 of bridge 3 and port 3 of bridge 3 and port 1 of bridge 5 are all said to be blocking ports. It means they will be there, but no frames will be sent out through this port. And by this way, and this algorithm is said to be called as spanning tree algorithm. And using this logic or using this algorithm, now we have that is the loop problem in bridges can be avoided. Hope it is clear. You have any doubt? Do you have any doubt up to now? So even if you do all this, we still have certain limitations in bridges. You cannot, these bridges, with the intelligence that these bridges have, it cannot interpret high level of information. And again, they cannot filter packets according to the protocol. So we go for the next level of connecting device for the next layer, which are said to be called as routers. So routers, what is this router all about? Is a 3-layer, that is the 3rd layer device. It means it is going to do the functionality meant for physical layer, data link layer, as well as the network layer. It's a 3-layer device, and the work of this connecting device is said to route the packet based on the logical address. Okay, so this actually is meant for connecting LANs with WANs in the internet. So how it actually does this? It is going to have a table called as routing table, and based on the information present in the table, it takes decision. It has intelligence which is capable of making decision about the suitable route that could be taken. Yes. So some more points relating to routers. They are again another type of interconnecting device, and they are capable of transferring packets. it has an intelligence which can able to deliver the packets to the destination. So this is how a routing table will look like. So it will contain the network address, which means it indicates the path used by the router, and it will also specify the node address. It is said to be the device address on the network. So you can able to see, if I say I'm going to connect 3 networks in using a router, then each of the network will have device, and each of the device will be having a specific address, and that address, see here, you can see in the diagram, we have the device with the name, with the address given as 1.2. 1.2 implies it is the device associated with the network 1, and the device address is said to be 2 in the network 1. Likewise it goes. So this is how the routing table addressing in the network layer is going to be available. So what is actually the difference between these routers and the bridges? First, bridges, that is bridging of bridging process takes place, or we use bridges, which is to be useful in the data link layer, whereas routing routers are meant for the network layer. Okay, and the second major difference you find is bridges, they use MAC address, whereas there is going to be a different addressing scheme that is going to be used by routers, which is available at the third layer, that is in the network layer. So this is all about routers. Now we'll move on to gateway. What is actually a gateway? So a gateway is said to be available in a computer, and it is the connecting device meant for all 5 layers of the internet. That or it could be the 7 layer as per the OSI model. So what actually is that it actually meant for connecting 2 devices which are differing in their protocol. So I say if one device is said to be using, or if I say if there is one system which actually works with OSI model, another one which is going to be using the TCP IP model, and if I have to connect them together, then I use the gateway. Okay. So this gateway will have all the provision required to connect these 2 different network which differ in the protocol. So now moving on to the switches. So we have network switches, which could be a backbone, which is just a single switch, or it could be a switch, a 2-layered switch, which is nothing but a bridge with more ports, and it could also be a switch, a 3-layer switch, which is similar to a router. So what is this 2-layer switch? So this 2-layer switch is said to be a bridge, but here the bridge or a 2-layer switch, we sometimes even call it as a bridge, is going to have many ports than the normal bridge with only 2 ports. Okay, so what is the difference between them? The difference between this 2-layer switch and the bridge, it means they are capable of better performance than a 2-port bridge. So if I can say that a bridge with at most 2 or 3, I can say it's a bridge with 2 or 3 ports can able to connect only few LANs. Whereas if I have a 2-layer switch, which we even call it as a bridge, will have many ports and the ultimate result is said to be capable of connecting more LANs together. Okay, so this 2-layer switch with or a bridge with many port is able to will have a capability to allocate a unique port to each station, so that each of the station is capable of acting independently, so that we can say the traffic can be reduced. Okay, and like your bridge, this 2-layer switch is also having the filtering filtering capability. It means based on the MAC address of the frame it receives, based on the table that is to be available, it will send the, what to say, it will send the frame to the destination address only. Okay. Or in other words, I can also say that compared to a bridge, this two-layer switch will have more features. I can say that it has a buffer so that the data, that is the frames, during the process of during the processing phase, it can be stored for shorter duration of time. Okay. So that is all about this two-layer switch. Now coming to the three-layer switch, this three-layer switch is similar to a router which is useful in the third layer, but here the difference is in the faster and more sophisticated operation. Okay, so that is all about the three-layer switch. So do you have any doubt up to now? You can ask me. So do you have any doubt up to now? You can ask.